Paterno-Bucci reaction, and in that particular reaction, uh, can you see the whiteboard?
Yes, ma'am.
Okay.
Yes, ma'am.
So let us quickly revise the Paterno-Bucci reaction. In the Paterno-Bucci reaction, what are the important things we have discussed? We have discussed that the reaction is specifically 2 plus 2 cycloaddition reaction. Another point we have discussed, there are two substrates. One substrate is the carbonyl containing compound, and the other substrate is a olefins. It may be a double bond, it may have triple bond. And the third point is that is the most important point over here, that is the energy of uh, carbonyl containing compound and the energy of the alkenes in a triplet state, of course. So energy of the carbonyl containing compound in a triplet state should be less than the energy of the triplet state of the alkenes, because if it has a higher energy, then it will easily transfer its energy to the alkenes, and the free radical in alkene will be generated. Once the free radical in alkene will be generated, then it will have a tendency to undergo dimerization or formation of cycloalkanes, etc. So we don't want such type of dimerization or cyclization. We are interested in formation of the oxatine. What is the meaning of oxatine? Oxatine is nothing but the four-membered ring having oxygen in a as a heteroatom in a ring. So these are the very specific examples, very specific characteristics of the Paterno-Bucci reaction. And another most important thing is the nature of mechanism will change as per the substituents on the alkenes. So we see that if the substituents are electron donating group, the mechanism will little bit change. If the substituents are electron withdrawing group, again the mechanism will change. So in overall, what we have seen, if the substituents are electron donating groups, then it will produce, if the cis substituents are there, you will get the trans product, right? And if you have a cis substituents in the reactants, so in the product you will get a cis one. Sorry, it is a vice versa, means trans will give you cis and the cis will give you a trans thing. But in case of the electron withdrawing group, what we have seen that the cis reactants will give you cis product and the trans reactant will give you trans product. The reason behind that, the energy associated with the HOMO of all the alkenes. More HOMO, more will different will be the mechanism. Less HOMO, different will be the mechanism. So these are the all characteristics we have discussed. Another, the most important point we have seen that it has if the stability of the free radicals are very very important over here. So we always seen that the reaction proceeds via formation of several intermediates. First intermediate, second intermediate. The very important thing over here, that the first connection we have formed over here with oxygen and the other free radical of the alkenes. So the most important point to be remembered over here, so you have to make connections first with the very very unstable free radicals. So very unstable free radicals, they are more reactive. So you have to first identify which are the most reactive centers in both the species, that is in the what we can say in the carbonyl containing compound as well as the alkene. So identify the most reactive species and get connection with both reactive species, and you will get the formation of another intermediate, which is nothing but the diradical, and that diradical is highly stable, right? And then in the second cyclization, and you will get the formation of oxatine. So these are the very important key points to be remembered whenever you conduct any mechanism in the right. So this is how you have to conduct. Hello, hello.
Yes,
Yes,
ma'am.
ma'am.
Can
Yes,
you hear
ma'am.
me?
Yes, ma'am.
So, so these are the important points regarding the stability of the various radicals and the reactivity of the radicals. Then the next reaction is a photoreduction reaction. Now, this photoreduction reaction is nothing but the uh, it is so this photoreduction reaction means reduction of the carbonyl group. This is the reduction of the carbonyl group by photochemistry. So the reduction of carbonyl group by photochemistry. Now, what are the important things to be remembered here? And this is a very popular reaction in the photochemistry. This is a very popular reaction in the photochemistry. Why this is popular? Let us see how it is popular in the photochemistry. As far as the Norris type 1 and Norris type 2, these are also very important reactions. Paterno-Bucci, of course, we have already discussed. And the photoreduction reaction means the reduction of carbonyl group in the ketone or aldehyde. Now, let us see the various characteristics of this reaction. As I always discuss the important characteristics, how you have to identify that particular this reaction is photochemical reaction, this reaction is photoreduction reaction, or this is a Paterno-Bucci reaction, or this is Norris type 1, Norris type 2. So depending on the various characteristics, every reaction has its own characteristics, which we have already discussed in the previous lecture. So similarly, the photoreduction also has some peculiar characteristics, and those characteristics let us see. Now again, the photoreduction reaction is initiated by photoreduction reaction is initiated by n-pi transition. Okay, so every whenever you start any reaction, you must know that how the reaction is initiated, because once the light is incident on your substrate, so what type of transition will take place over here, that you must understand, you must know. So every time whenever I start any type of characteristics, I always tell you, or I always explain you how the reaction is initiated. So please do not ignore this point, because this is the only point first come in your mind. It should come in your mind that how the reaction is initiated. So the reaction is initiated by n-pi transition, right? Now this n-pi transition, why it is initiated by an n-pi transition? As we always know that the carbonyl containing compound has a lone pair of electron, etc., etc., and that's why the n-pi transition, it can be easily possible over here. Now once the n-pi transition takes place in the reaction, then what is going to happen? Again, the alkoxy radical, and the alkyl radical will form. alkyl radical they will form. So the formation of alkoxy radical and the alkyl radical takes place, or they are generated over here. So please remember that in which reaction we have seen the alkoxy radical and the alkyl radical they are generated, of course in the Norrish type 2 reaction. So this is similarly a Norrish type 2 reaction, where what we have seen, that we have seen there is a formation of alkoxy radical as well as a alkyl radical. So this reaction is similar to Norrish type 2 reaction. This reaction is similar to Norrish type 2 reaction, but the mechanism is a little bit different. Then what are the substrates we are using? Of course, we are using the substrates. Substrates are the carbonyl containing compound, the carbonyl containing compound, and substrates. Whenever I am talking about substrate, it means that there are more than one substrates, means the other substrate will be a what we can say, a hydrogen donor, suitable hydrogen donor. It can be a suitable hydrogen donor. So So we'll see which type of substrate by structure, right? So the substrates are carbonyl containing compounds and the suitable hydrogen donors. Okay, so these are the substrates of your photoreduction reaction, and how the reaction proceeds in the forward direction. That due to abstraction of hydrogen, due to the abstraction of hydrogen from a hydrogen, from a hydrogen. Who abstracts? Of course, the oxygen abstracts the hydrogen from the hydrogen donor. That you must understand. So the abstraction of hydrogen from hydrogen donor uh, will give you the reduction of carbonyl group. Reduction of carbonyl group. It gives you the reduction of carbonyl group, and which accomplished under photochemical, under the photochemical condition. Right. So these are the main characteristics of the photo reduction reaction. So again, I will revise the characteristics. The photo reduction reaction is initiated by n-pi transition. Due to the initiation by n-pi transition, alkoxy radical as well as the alkyl radical will form, and this reaction is just similar that of the Norrish type 2 reaction. And what are the substrates we are using over here? We are using a benzophenone or a carbonyl containing compounds and the other suitable hydrogen donors, right? So due to abstraction of hydrogen from the hydrogen donors, the carbonyl group gets reduced, and you will get the formation of photo reduced product. So let us see the general mechanism, general representation of the reaction. The general representation here, it looks very simple, but again I always tell you that in the photochemical reaction, the reaction requires lot of basic knowledge. So what we think it will never happen, because of the several basic concepts are involved in this reaction. So for this is a benzophenone which undergoes photochemical changes, and in the presence of proton donor, the reaction will give you this product. The reaction will give you this type of product, and this is called as a pineapple. This is called as pineapple. So benzhydryl, benzhydryl. So benzhydryl will give you a pinacol. So combination of two benzhydryl will give you a pinacol. So this is this particular product is called as a pinacol, right? And what type of hydrogen donors we are using over here? Hydrogen donors. Hydrogen donors can be isopropyl alcohol, or it can be a cumene also. It can be a cumene. What is the structure of cumene? Cumene is like this. So these are the various hydrogen donors we can use in the mechanism in the reaction. Now let us see the actual mechanism, how the reaction proceeds in the mechanism. Right. Now mechanism is, I am taking this benzophenone as a first moiety. It undergoes H nu. So at the proper triplet state and pi transition, then definitely it has ISC, which gives you triplet in the n-pi transition. So I am writing the n-pi transition in a triplet state over here, the structure of n-pi transition in a triplet state. So this is a triplet state of the benzophenone. Now what is happening over here? So this oxygen is highly reactive. This oxygen is highly reactive. You know that. As we have seen that this is highly reactive center. So it now the another moiety which it requires is a hydrogen donor. So what is happening here? It abstracts the hydrogen. So oxygen abstracts hydrogen from this hydrogen donor. This is nothing but the hydrogen donor. This is isopropyl alcohol. Right. Now the proton is abstracted by the oxygen, and you'll get the formation of this product, this radical, of course. So this H is abstracted, so you will get the formation of, so but this radical will remain same, and generation of other radical takes place. तो विच इज यहाँ से हाइड्रोजन निकल जाता है, तो as we know that free radical generates free radical, so there is no question of forming carbanion or carbonium or etc. other intermediate, so you will get the formation of another free radical. Now this free radical has a capability to donate another proton. Another proton. So another benzophenone, another benzophenone, another the second molecule of benzophenone uh, is participating over here. Again, same procedure will take place in a triplet state. It undergoes in a triplet state, and this hydrogen, this hydrogen will be abstracted over here. So again it generates, so this will be your first step and this will be your second step. Now this, now you just forget about this moiety which is formed in the first reaction, right? So let us see this, this free radical has a capacity to form, to react with the another molecule of the benzophenone, and again it generates other benzadrel, right? So here overall we have now two molecules of the benzhydryl. So this is the, this is my first molecule which is generated in the first attack, and this is my second species which is generated in the second attack. Both are same, but they are formed in a different stages or different steps. So that's why I have labeled them as A and B. So two radicals are formed. So these are the benzhedral radicals. They are the benzhedral hyd- benzhedral radicals, right? So two benzhedral radicals are formed in a one reaction, and now these two radicals which are formed, they undergo dimerization. Now, what is happening with this molecule? With this isopropyl radical, so this will go. Let us see. Now, whenever this benzhedral radical will form, so simultaneous it it gen it generates ketone over here. It generates ketone over here. So when when this benzhydral will form simultaneous, there will be a generation of acid, because this hydrogen will be abstracted by this oxygen, and this oxygen again become benzhydral, and here there is a formation of acetone. Now these two benzhydral radicals, they are ready for the dimerization. So here now these two radicals which are formed in the two different steps, so I'll right now they are this is called as phenol. This is called as phenol. Okay. So do you understand how the reaction proceeds in the forward direction? Yes.
Yes, ma'am.
समझ में
Yes,
आया?
ma'am.
Yes, ma'am.
Only you have to remember that this at this point. See, up till now it will be okay, but you have to remember that this free radical has a capacity to donate a proton, and because of this it can generate the another free radical. Okay, so overall we can say that overall reaction we can say that two molecules of benzophenone, two molecules of benzophenones react with one molecule of isopropyl alcohol gives two benzhedral radicals so these two benzhedral radicals undergo dimerization. Accomplished phenol. So this is the beauty of reaction, that two molecules of benzophenones are exhausted in the photochemical reaction. So one molecule of this isopropyl alcohol has a capacity to reduce has a capacity to reduce the which reduces this two molecules of benzophenone. Understand? So this is the mechanism, general mechanism, and it looks very simple, but only thing you have to remember that at this point again you have to start a new refresh reaction, because this is a free radical, so it has a cup. So now in this case there is no need there is no need for what we can say, the excitation, right? In very few minutes I told you that again you have to write the excitation, the singlet. No, there is no need, because why? Because already this free radical has been formed. So this free radical has a very much capacity to generate another free radical, right? So after abstracting hydrogen, another free radical is formed, and this is how the reaction is generated. The initiation, propagation, and the termination of the reaction takes place. So if you have any doubt in this mechanism, so I gave you a minute. So let us have some discussion, otherwise, I will proceed. Yes, you have any problem? Any doubt? Hmm? Is
Ma'am,
it okay?
acetone.
Please.
Hello.
हां.
मॅम तो ऍसिटोन कसा काय आला म्हणजे एकदा ते पुन्हा repeat?
हा ॲसिटोन जो
हो
जनरेट झाला इथून हायड्रोजन हा फ्री रेडिकल फॉर्म झालेला इथपर्यंत कळलं?
हो मॅम.
हा. मग आता हा जो आहे ॲसिटोन कसा फॉर्म झालेला आहे, हा हायड्रोजन कोणी एक्स्ट्रॅक्ट केला? दिस मॉलिक्यूल,
ऑक्सिजन.
है ना? हा ऑक्सिजन जसं त्यांनी केला तसं काय होईल, आता याचं मी सेपरेट तुम्हाला मेकॅनिझम सांगते. पण याला आता याच्यामध्येच ठेवू, ठीक आहे, रॅडिकल फॉर्म मध्ये करू याला. So this is the hydrogen which can be easily donated. हा ऑक्सिजन जो आहे बेन्झोफिनॉनचा, it easily abstract the hydrogen from this center. So what is happening over here? Already free radical is there. So oxygen develops another free radical, because see, free radical always gives you free radical. Now here, got it now? That's it, very simple.
ओके मॅम.
समजलं?
हो मॅम.
जर नाही समजलं तर लगेच फ्री रॅडिकल फॉर्म मध्ये त्याचं कन्व्हर्शन करून घ्यायचं. फ्री रॅडिकल मध्ये कन्व्हर्जन केल्याबरोबर मेकॅनिझम क्लिअर कट म्हणजे समोर येतं की कशा पद्धतीने झालेलं, राईट? एनी डाऊट? येस.
नो मॅम.
So shall I proceed?
शुअर
So
मॅम.
who is absent today? Harish. Who is absent? Memunsha. Harish and Memunisha are absent today. Am I right?
Yes, ma'am.
Okay. So next, so this is a general mechanism we have seen, which is now I always explain you the substituted and the symmetrical, unsymmetrical, because the chemistry revolves around the symmetry of the molecule. Now here, the very important note over here, that in the Paterno-Bucci reaction also, what we have seen, if we put electron withdrawing groups on the substrate, the chemistry will be something different. If we put electron donating groups on the substrate, again the mechanism will be changed. Now here, the important point here we have discussed, we need to discuss over here, that is the so the benzophenone. Now, benzophenone, when they are unsubstituted, if the benzophenone is unsubstituted, you can see the mechanism. It goes very smoothly in the forward direction. The mechanism undergo very smoothly in the forward direction. But if the benzophenone is substituted with electron donating group, electron donating groups. So it will not undergo photoreduction. Okay, so photoreduction does not take place. Photoreduction does not take place. What is the meaning of that? Electron withdrawing groups, sorry, electron donating groups deactivate the benzophenone ring. Due to that, n-pi transition will not take place. How it is deactivated? These are the couple of reasons I am explaining. Right. So if electron donating groups are present in the molecule, in the benzophenone, what is going to happen? The benzophenone moiety is deactivated, and the n-pi transition will not take place, where n-pi transition is not taking place. But what is happening here? It was explained that the pi-pi transition is possible. Here it has been explained that the instead of n-pi transition, so how the complete scenario we can see as a point of photochemical reaction. So this is a simple benzophenone where we can see that there is a n-pi transition, there is a ISC, again triplet state of n-pi transition. And what is the beauty of this reaction? The oxygen of the triplet state in the n-pi transition. So how many factors are important for the abstraction of hydrogen? So remember, these are the factors. Which are the factors? The first factor is n-pi transition is very important. Similarly, the triplet state of the n-pi transition and the oxygen in the triplet state. Oxygen in triplet state. So these are the three important factors which are responsible for the abstraction of hydrogen. So the triplet state of oxygen in n-pi transition state, this oxygen only in n-pi transition state, oxygen abstracts the proton from the hydrogen donor. So this is the important point to be noted over here. So in this case, so where it has gone, I have, okay. So benzophenone, which is substituted with electron donating groups, the photoreduction does not take place. Why? Because the electron donating groups, they deactivate the benzophenone. It means that n-pi transition will not take place. If n, though there is a transitions in the benzophenones having electron donating group, but which type of transitions we can see over here? So this pi-pi transition will take place in the benzophenone which are with the electron donating groups. So I can explain this as a, so this is a benzophenone at the para position, electron donating group, suppose right. So because of this, n-pi transition is not possible in this type of reaction, in this type of moiety. So pi-pi transition is possible, right? So pi-pi transition of the triplet state, the oxygen in the T1 pi-pi transition is not capable of abstracting a proton. See, everything is there. Proton donor is there. सब कुछ तामझाम वैसे के वैसा ही है, but the oxygen in the triplet state, this is a very important point to be noted over here, that the oxygen which is formed in the triplet state in the pi-pi transition is not capable of the abstracting a proton, and that's why the photoreduction is not possible. photoreduction is not possible. So whenever in the examination, if such type of example you can see, so you can directly say that this type of reaction is not possible because of this couple of two reasons. For the first reason is this reaction is initiated by pi transition, right? It means that it requires higher energy. pi transition कब होता है और n pi कब होता है? n pi तभी होता है जब उसका एनर्जी लेवल जो है बहुत हाईएस्ट है, ठीक है। और यहाँ इसको ज्यादा एनर्जी लग रही है, पाई ट्रांजिशन एन पाई को कम एनर्जी लगती है, यहाँ इसको ज्यादा एनर्जी लग रही है, एंड दैट्स व्हाई पाई ट्रांजिशन टेक्स प्लेस, though it undergo pi transition, but the oxygen which is in the pi transition in a triplet state is not capable of the abstracting a proton. अब ट्रिपलेट स्टेट को छोड़ ही दीजिए, सिर्फ इतनी बात याद रखिए क्योंकि आपको आगे बहुत ज्यादा, जब आगे रिएक्शन हो ही नहीं रहे तो क्यों सिंगलेट को याद करो, क्यों ट्रिपलेट को याद करो, जस्ट remember this thing, the oxygen in the pi transition is not capable of abstracting a proton, and this because of this reason photoreduction is not possible, right? So these are the two important points. Because of that the photoreduction in benzophenone having the electron donating groups, it is not going to happen. But if the groups are electron withdrawing groups, what is the status of electron withdrawing groups? So inversely, electron withdrawing groups activate the benzophenone ring. As it activates the benzophenone ring, then the photoreduction will be faster. Photoreduction is faster. Right. Now my question is, I have these three moieties. This is A. This is B. And this is C. Okay. So predict the order of reactivity. And justify your answer. So this is a homework. Okay, this is homework. Now other important point is, so one more important species we need to discuss over here. So this is a 4,4 dimethyl amines. Dimethyl amino benzophenone. So this is again a very interesting benzophenone. Okay. So this moiety is also called as Mishler ketone. This is also called as Mishler ketone. Now this Mishler ketone is upon photochemical excitation. What is exactly happening in this Mishler ketone, whether it undergo photoreduction or not? So this is n time. Now, up till now, what we have seen that after after irradiation, it undergoes singlet state, it undergo triplet state. But in this particular moiety, which is a 4,4-dimethylaminobenzene, which is nothing but the Mishler ketone, which is nothing but the Mishler's ketone. So it absorbs energy, and upon photoexcitation, it undergoes intramolecular electron transfer. So here the intramolecular means within the molecule, intramolecular electron transfer takes place. Intramolecular electron transfer takes place after uh, photoexcitation, and thus the excited state is a charge transfer state. Okay, so this is a excited state, no doubt, but instead of forming the free radicals, instead of forming a free radical here, the charge transfer state, the this is also called as a charge transfer state और CT state आपने काफी बार सुना होगा. That is a city state. So upon a photo excitation, it absorb energy, but instead of forming any singlet state or a triplet state or a free radical, the intramolecular electron transfer happens over here. So this intermediate is nothing but the charge transfer state. Okay, now this charge transfer state, the oxygen of this charge transfer state, again the oxygen, particularly the oxygen of the charge transfer state is not capable of abstracting hydrogen, is not capable of abstracting hydrogen, is not capable of abstracting hydrogen. Right? And again, that's why the photoreduction is not possible. Thus, photoreduction is not possible. That's got it. So these two factors you have to remember, that which reactions, which moieties undergo photoreduction, or which moieties which are not showing any photoreduction. So you have to also justify the reason why they are not undergo photoreduction, and why some moieties they easily undergo photoreduction. So these are the important points to be remembered over here. Now so I will explain another that is a mechanism, and then we'll end up here regarding the photo reduction reaction. ये समझ में आया सबको? Yes?
Yes, ma'am.
Yes,
Easy है?
yes, ma'am.
Easy है? इसको बार बार पढ़ना पड़ेगा आपको, कुछ कुछ बातें बहुत पिक्यूलियर है, बहुत इंपॉर्टेंट है, वो आपको ध्यान में रखनी है, राइट। नाउ अनदर मैकेनिज्म इज नथिंग बट द फोटो रिडक्शन थ्रू इलेक्ट्रॉन ट्रांसफर मैकेनिज्म। One more. So I take a 10-second leave. Okay. So should I stop over here? So tomorrow we'll see. Okay. Is that okay?
Yes, ma'am.
Yes, ma'am.
We'll see it tomorrow. We'll revise some more points, and we'll discuss the photoreduction through electron transfer mechanism, and we'll discuss the. So this is a very small part remaining regarding the photoreduction reaction, and we will discuss the problems which are given you in the last lecture, in last lecture. That is a Norrish type 2, है ना? वो आपको डिस्कस करने पड़ेंगे ना, आपके सही है या गलत है, राइट। So this mechanism and the problems which are given which were given in last two lectures, so we'll discuss, and some more Paternobuchi will discuss by tomorrow morning. So I think by tomorrow morning 9 o'clock will be okay.
Yes,
Yes.
ma'am.
Yes, ma'am.
Okay. So we'll engage your class by tomorrow morning 9 o'clock, right? Okay. So अभी आप आ जाओ online. Please do come on online. Okay. Online आ जाओ भाई. Okay. Thank you.
मॅम
हाँ.
स्लाइड्स किती बनवायच्या म्हणजे सेमिनारसाठी?
25 मिनिटात सेमिनार आपल्याला संपवायचा असतो. ठीक आहे, त्याच्या अकॉर्डिंग